Hello and welcome to Mathematics with Simon. I'm Simon. Today we're going to look at curve sketching as part of the A-level mathematics syllabus. So curve sketching is useful because it allows us to check algebraic results, find roots and limits, and generally understand functions between variables in more depth. Understand what happens at infinity, what happens at zero, if there are any singularities, that kind of stuff. There are 6 steps to sketching a curve. Work out the y-intercept, the point at which it hits the y-axis. The limit of y as x tends to infinity and minus infinity. The maxima and minima, so the points where dy by dx equals 0. I mean, dy by dx can also equal 0 at inflection points, but basically, well, inflection points are interesting too, but basically the maxima and minima are very helpful when understanding the shape of a thing. The roots, which is the point where it hits the x-axis, they're like the x-axis equivalent of the y-intercept, but they're a bit harder to calculate often, although not always. The singularity is where y goes to infinity or minus infinity or something like that. Is this an odd or an even function? And we'll explain what odd and even function mean. So the y-intercept, what is the value when x equals 0? So for polynomials, we just read off the constant because all the other terms involve x, so when x is 0, those terms just disappear. So the constant is the y-intercept. The limit of y as x tends to infinity and minus infinity. So for a polynomial, we ask what the highest power is. We call this n. So let's say the highest power is 2, so it's a quadratic. Then basically, and let's say it's just x squared on the front, then as x goes to infinity, that's going to go to positive infinity because the x squared term will dominate. And if x goes to minus infinity, it'll also go to plus infinity because minus 10 squared is 100 and minus 1,000 squared is 1,000,000, and minus 1,000,000 squared is 1,000,000,000,000. So it goes, as you go to a more negative x value, it goes to a big positive value. But whereas on the other hand, if the highest power was kind of 3, so it was x cubed, then 100 cubed is 1,000,000, but minus 100 cubed is minus 1,000,000. So actually, as x goes to minus infinity, y is going to minus infinity too. So that's different. We've got a little table here. So if the highest power is even and its coefficient is positive, then as x goes to infinity, y goes to infinity, and as x goes to minus infinity, y also goes to infinity. If the highest power is odd and the coefficient is positive, then y mirrors x. So as x goes to infinity, so does y. As x goes to minus infinity, so does y. But if n is even and the power is negative, then in a sense, instead of a sort of U shape, you've got a sort of dome. And x goes to minus infinity in both cases because the even power will always be a big positive number, and then if you stick a negative coefficient on the front, it'll always, you'll get a big negative number when you go to plus infinity or minus infinity, and so on. So that's just good to know, which is what happens, and there are things that aren't polynomials, and we can deal with them in case by case. Next, what are the roots? So in the case of polynomials, you're looking for linear factors of the form x minus r. This is what you do when you solve a quadratic or a cubic. You're looking for those roots, those numbers that make it equal to 0. So in other cases, or also in the case of polynomials, we're just looking for values r for which f of r equals 0, the function of r equals 0. And then also you get singularities, and they're kind of roots of the denominator. So in some cases the denominator will be like x, in which case the roots are just 0, and so you'll have a singularity at 0. But let's say the denominator was x plus 2, then you'd have a singularity at minus 2, because when you put in minus 2 you get 0 on the bottom, which is kind of impossible to calculate, or it's kind of infinity, although it's probably going to plus infinity or minus infinity depending on which side you're coming from. So it's kind of indeterminate. So an even function is a function that's symmetric around the y-axis. So y equals x squared is symmetric around the y-axis. It's an even function. And for even functions, f of c equals f of minus c. F of 6 equals f of minus 6. 6 squared equals minus 6 squared. Odd functions have rotational symmetry order 2 around the origin, so you can spin them by 180 degrees and they fall back on themselves. So y equals x cubed is like this, y equals x is like this, y equals x cubed, if you just rotate it by 180 degrees, you put a pin in the origin, and rotate y equals x cubed by 180 degrees, it just lands back on itself. So that's an odd function. And kx to the n is an even function if and only if n is even, and kx to the n is odd if and only if n is odd, or actually, if you look, if n is 0, then kx to the 0 is actually k. It's just a constant, which is actually, it is even. This is more complicated than I thought it was. Imagine, we're going to just forget n being 0, because that's a really problematic thing, because if n is 0, it's good to do a bit of maths in real time, then x to the 0 is 1. And that is an even function, but it's not an odd function, so that's not true. So kx to the n is odd if and only if n is odd. That's true. Okay, progress. Okay, next. Y equals 3x plus 5. So we're going to sketch y equals 3x plus 5. So point 1, the y-intercept is 5. We're touching the y-axis at 5. Point 2, there's a root at, so if you set this equal to 0, this is equal to 0, so 3x equals minus 5. So x equals minus 5 over 3 minus 1 2/3. And there we are, minus 1 2/3. That's where it's intersecting with the axis, which is really helpful. It's just a straight line. It's just a straight line. So once you've got 2 points, you can just draw the straight line. Easy peasy. Next, y equals x squared. So what's to say here? It goes to plus infinity on the right, plus infinity on the left. When x equals 0, y equals 0, so it hits the origin. So the y-intercept is 0, and the roots are at 0, and it's got that kind of traditional parabolic shape. It's a parabola. Here's another parabola, y equals x squared minus 3x minus 4. This is slightly different, and we're going to, because we're clever people, we're going to solve it in real time. So we're going to say this is x minus 4 times x plus 1, which tells us that the roots are minus 1 and plus 4. So it's hitting at minus 1 there, it's hitting at plus 4 there. And the y-intercept is at minus 4. So you've got a parabola going through. It's easy to draw. Once you can do this, it's the coefficient of x squared is positive, so we're going to plus infinity and plus infinity on either side. We're going through minus 1, we're going through 4, we're going through the x-axis, we're going through, on the y-axis, we're going through minus 4. And we're hitting the x-axis at minus 1 and 4, and so we can just draw it like this. What I've done here is also done the derivative. So the derivative of x squared, if you haven't done calculus yet, don't worry too much, but the derivative of x squared minus 3, this is all to come, and it's very interesting. Derivative of x squared minus 3x minus 4 is 2x minus 3. So you set that to 0 for the minimum point, which tells you that x equals 3 over 2, which is just there, 1.5. So once you've got those 4 points, it's pretty easy to just draw a parabola between them. This is y equals e to the x. Again, if you haven't done this yet, don't worry. And it's fascinating because its derivative is also e to the x, as is its second and third and fourth and nth derivatives. They're all e to the x. So what does this tell you? Well, the first thing is when x equals 0, we can work out the y-intercept, put in a 0 there. Y equals e to the 0, which is 1. 4 to the 0 is 1. 10 to the 0 is 1. I mean, anything to the 0 is 1. We've done a video on this. Anything to the 0 is 1. Except you worry a bit about what 0 to the 0 is. That's a more complicated conversation. But e to the 0 is 1. So it goes through 1. And then you've got no maxima or minima because dy by dx is never 0. Because e to the x is never 0. Even if you put in a massively negative number, it's just 1 over, if you put in e to the minus n, where n is a big number, just 1 over e to the n, which is not 0, it's just really small, as we can see from the chart. So there's no maxima or minima. And then as x gets large, this just gets enormous. So e to the, well, you can see e to the 6, e to the 7, it's exponential growth, it takes off. This is actually what we saw during the pandemic. This is the growth of cases in the pandemic. It's the same shape, which is that if something keeps doubling or keeps being multiplied, e is a bit bigger than 2, but keeps being multiplied by the same number, it gets big very, very quickly. And there's lots of interesting stories about that. We'll do a video on that in the future, exponential growth. Note to self. Here's a more complicated one. Here's a cubic, beautiful, beautiful curve. Y equals x cubed plus 2x squared minus 25x minus 50. It's kind of contrived so that it factorizes. In fact, well, we can see from the chart what the factorization is because we've drawn the chart actually, but let's just write the factorization just to make it simple. So the factorization is x minus 5 is one factor, x plus 5 is another factor, so you've got this kind of difference of two squares in the middle there, and then x plus 2 is the final factor. So if you actually write it out, the difference of two squares comes out to x squared minus 25, and then this is like x plus 2. And if you multiply that all up, you can kind of see it works because you get x cubed, then you get plus 2x squared, 2 times x squared, minus 25x, minus 25x, minus 50. It all kind of works. And then you've got these roots. So you've got a root here at 5, you've got a root here at minus 5, you've got a root here at minus 2. And yeah, so what you do is you say, well, those are the roots, so it's got across the axis there. Then you say it's got to go to plus infinity on the right and minus infinity on the left because you've got a odd numbered coefficient and you've got an odd numbered power and you've got a positive coefficient. So it's just x cubed. So clearly, if x is 100, this is positive 1,000,000, and if x is minus 100, this is negative 1,000,000. So as x becomes very negative, x cubed becomes very, very negative. So it's going down here and up there, and it's touching the axis here and here, and the y-intercept is minus 50. There it is, minus 50 for the y-intercept. And actually, we've done the exercise here just to work out dy by dx is 3x squared plus 4x minus 25. Solve this by the quadratic equation for when this equals 0, the quadratic formula for when this equals 0. And you get minus 3.6 or 2.3, and there's minus 3.6, and there's the other one, 2.3. So those are the turning points. You don't really need the turning points. I mean, you can kind of sketch it a bit more nicely, but once you've got the y-intercept and you've got the infinite values and you've got the roots, we can roughly know what shape it is. Y equals 1 over x, so it's got no roots and it's got no y-intercept. But you do know that when x is 0, it's got this indeterminate behavior. And the point is, when x is 1,000,000th, then y equals 1 over x is 1,000,000. And when x is minus 1,000,000th, y equals 1 over x is minus 1,000,000. And that's why it's going whoosh down to minus infinity and whoosh up to infinity all around 0, which means that you can't have a value at 0. It's really indeterminate, which is kind of fascinating. And that's why you get the picture you get. And then, of course, as x, in this case, as x goes off to infinity, 1 over x just goes to 0. And as x goes to minus infinity, 1 over x also goes to 0, but from the kind of bottom, not from the top. So this is 0 from the top, this is 0 from the bottom. I hope you like this video. I always like making them. You're very welcome to subscribe and hit the notification bell. I'd love to hear your ideas. And most of all, I hope we all enjoy our mathematics together.